Right. Uh, Today we are going to learn about non-deterministic push-down automata. Okay, it is uh, it is a push-down automata, but non-deterministic in nature. What do we mean by non-deterministic? That on a single if I am in a particular state and on a single input symbol, then I am going, there are multiple possible transitions. There are two or more possible transitions on a given input symbol. So that is a non-deterministic system. So the example that we have taken is a non-deterministic push-down automata for recognizing odd or even length palindrome strings over the alphabet set A, comma B. Okay. Now, if you look at the strings that are present in the language, the strings can be of the form A, B, it can be of the form AA, which is an even length palindrome string, or it can be of the form ABA, which is an odd length palindrome string. Okay, so we are trying to draw a push down automata for recognizing an odd or even length palindrome strings, and we are going to draw a non-deterministic push down automata. So this is the diagram that is drawn for recognizing an odd or even length palindrome string. Okay, now if we consider an odd length string, odd length palindrome string, then there is always a central element present. Either it will be an A or it will be a B. In case of an even length palindrome string, we consider epsilon to be the central element. Okay, so epsilon happens to be the central element for recognizing an even length palindrome string, and in case of odd length, either an A will be there or a B will be there to say it is a central element. Okay, now the central element is important because we want to match the left half of the string, that is the symbols that are present on the left half of the central element should match the symbols that are present on the right half. Okay, so we need a central element. So in case of an odd length palindrome string, it is an A or a B, and in case of even length palindrome string, we are considering it to be epsilon. So if you look at the diagram, this is a non-deterministic push down automata. So the states that the first state is the start. From start we move to read one, and in read one, whenever I see an A, I push that A onto the stack and I go and read the next symbol. If I see a B, I push B onto the stack and I go and read the next symbol. Right. Now, the first read one takes care of all the symbols that are present to the left hand side of the central element. Okay. So, if an odd length palindrome string, we said it would either be an A or B as a central element. And in case of even length palindrome string, we are considering epsilon. So, the read one part actually takes care of the left hand side of the string, because the logic is that, or the algorithm is that we push all the symbols that are present on the left hand side of the central element onto the stack, and then when we reach the central element, we, for every element that is present on the right hand side of the central element, we pop a symbol from the stack. The element that is popped from the stack and the symbol that is being read should be one and the same. If it is the case, then we continue this process till such a time that we have reached the end of the string and stack is empty. Okay, so at any point of time when we pop an element from the stack and the symbol that is being read do not match, that means the string is not palindrome. So I need to push all the elements which are present on the left hand side of the central element onto the stack, and that is taken care by read one. So when we are in read one, we are taking care of all the elements on the left hand side of the string. We push those elements onto the stack. Now, whenever I see the central element for an odd length string, it will be either A or B, and for an even length string, the central element is epsilon. Then we move from the state read 1 to read 2. So moving from state read 1 to read 2 on A, B or epsilon is representing the condition that we saw a central element, an A or a B in case of odd length palindrome and epsilon in case of an even length palindrome. Now if we look here for read 1, we have on input symbol A two transition paths, and on input symbol B we have two transition paths. So that is how the system or your machine has become a non-deterministic push down automata. In read 2, when we come to read 2, it means now we have reached the second half of the string. So for every element that is read from the string, from henceforth we pop an element and check whether they are matching or not. So at read 2, when I see an A, I pop an element from the stack. The popped element is A. Okay. If it is the case, then I go and read the next symbol. If the pop element is a B, if the red element is a B, then I pop an element from the stack and I check whether it is a B. So the two symbols match. If that is the case, we go back and we read the next symbol. This process is process is continued till such a time either we have reached the end of the string, in which case I will read a blank. If I read a blank, I pop an element from the stack, that is with pop 3, and the element that is popped from the stack, if it is also blank, that means the stack is empty and I go into an accept condition. At any point of read 2, if I read an A but the popped element is not an A, or if I read a B but the popped element from the stack is not a B, that means the string is not palindrome, and in which case we will reject the strings. Okay, again this is a non-deterministic push down automata, which which is where we accept the string belongs to the language based on the concept of empty stack method. Okay, so when I reach the end of the string blank, and if I reach the blank, if I pop an element from the stack and that also is blank, then we go into an accept state. Okay, so this is the algorithm that is being used to draw this non-deterministic push down automata. So I have shown the simulation for an odd length string and an even length string. So if I consider an odd length string like triple A, where the second A is the central element, then the initial state happens to be start, the stack contents is blank, and the tape head is at the first position or the first symbol of your string. Okay, from start 1 I go to read 1. The element that I'm reading is an A. Since it represents the left half of the string, I push that element onto the stack. Okay, so nothing happens to the stack contents, but because I have read a symbol, the read head moves one place to the right. Now in step number 3, since I move to this state called as push A, I push an element onto the stack. So A is present on top of the stack, and the tape head remains at the same position. From push A, I go back to read 1. The symbol that is being read is an A. Now this is our central element. So we move from read 1 to read 2. The stack contents remain the same and the read head moves one place to the right. Okay, since we've already found our central element, now we have to match the elements. The right hand side will be matched to the left hand side. So I pop an element from the stack. The element that is popped will be an A. Okay, and I see what is being what is what is we see that this A, the symbol that is read and the element that is popped are one and the same. So we go back to the state called as read 2. The symbol that is being read is a blank character. Because I have read a blank character, read ahead moves one place to the right. Now since I read a blank character, I go to the state called as pop 3. So when I pop an element from the stack, I get a blank symbol, and that is why I will go to an accept state. Okay, so the second simulation basically shows a rejection state where the string is BA, where the left hand side does not match to the right hand side. And because it is an even length string, I've considered epsilon to be the central element. So I start from start. The stack elements are blank and the tape head is at the first position. In step 2, I will read a symbol. Because these are symbols present on the left hand side of the central element, I will push the B onto the stack. The stack now contains a B. Okay, and then I'm going to read the next character, which will be an A. Since it is also present on the left hand side of epsilon, I will push that symbol also onto the stack. So by the time the read head moves to the epsilon symbol on the tape, we see that there are two symbols onto the stack, that is B and A. Now once I have read the central element, the elements that I will read will be the right hand side of the string, which should actually match to the left hand side if it is a palindrome string. So I from read 1, if I read an epsilon, I simply move to read 2. Now in read 2, the first element that I am reading will be a B, like in step number 6 the read head is at B. I will pop an element, but the element that is popped from top of the stack will be an A. So B does not match with an A, and hence the string will be rejected, saying that it is not a palindrome string. Okay, now I've taken a simple example for an even length palindrome string BB. So initially I have a start state, the stack is empty, the read head is at the first position of the string. When I read till I will push all the symbols onto the stack which are present on the left side of the epsilon, which is considered are to be the central element. The steps 2, 3, okay, represents pushing of B onto the stack. Now, step 4 shows that we move from read 1 to read 2 on reading the epsilon symbol. This has happened because epsilon is a central element. And since I have reached the central element, now I'm reading the right hand side of the string from step 5 onwards. Okay, we are reading the right hand side of the string. So we are going to see whether the right hand side will match the left hand side. So when I read an element from the right hand side, I will pop an element like in 6. The red element and the popped element are one and the same. So I will move the tape head one place to the right. Now since I read a blank character, I've reached the end of the string, I pop an element from the stack and I get a blank character. And since they are matching, we go into an accept condition. Okay, now this is about this is the non-deterministic push down automata for a palindrome string, either an even length or odd length string. Okay, now what we have to remember is that that a non-deterministic push down automata is greater in power than a deterministic push down automata, simply because the number of problems that a non-deterministic push down automata can solve is greater than the number of problems that can be solved by a deterministic one. So for every non-deterministic push down automata, there may not be an equivalent deterministic one. Therefore, our conclusion is a non-deterministic push-down automata is more powerful than a deterministic ones. That is, the class of context-free languages accepted by a deterministic push-down automata is simply a proper subset of the class that is subset of context-free languages accepted by a non-deterministic PDA. Okay, in simple words, more problems can be solved using a non-deterministic PDA than a deterministic one. An equivalent deterministic PDA may not exist for a non-deterministic push-down automata. Thank you.